Hello everybody and welcome back to another Algebra 1 video. Today we will be finishing out Chapter 4 with Lesson 4.5, covering solving systems of inequalities. In the past 4 videos, we've been working with systems of linear equations. However, for this last lesson, we'll be finishing off with learning how to solve a system of linear inequalities. Here is a brief introduction to what they are. A system of linear inequalities is a set of two or more linear inequalities in the same variable. An example would look like this. We have two inequalities in our system, the first being 2x plus y is less than or equal to 4, and the second one being 2x minus y is less than or equal to 0. They look very similar to systems of linear equations. However, of course, the equal sign is replaced with an inequality symbol. Similar to a system of linear equations, a solution of a system of linear inequalities is going to be an ordered pair that is a solution of each inequality in the system. We're going to begin with these two examples. They're asking us to tell whether each ordered pair is a solution of the system. We have our system right here. Inequality 1 is y is less than 2x, and inequality 2 is y is greater than or equal to x plus 1. Looking at our first ordered pair, we have 3, 5. Remember that an ordered pair is in an xy format, so you would simply plug in 3 for your x value and 5 for your y value into each of these inequalities. So here are our two inequalities in our system. I'm going to plug in 5 for y and 3 for x, so that would give me 5 is less than 2 times 3 for our first inequality, and for our second inequality we would have 5 is greater than or equal to 3 plus 1. And now you can just simplify this. For inequality 1, you would get 5 is less than 6. And for inequality 2, you would get 5 is greater than or equal to 4. Now you just evaluate whether those inequalities are true. 5 is less than 6, so that checks out. And 5 is greater than or equal to 4, so that also checks out. So we can conclude that 3, 5 is a solution of both inequalities, and since it satisfies both of our inequalities, it is considered a solution of the system. We can try this again with a different ordered pair. Now we have negative 2, 0. Negative 2 is going to be our x value, and 0 will be our y. Again, let's write down our two inequalities. And we're going to plug in negative 2 for our x value and 0 for our y value. So for our first inequality, we would have 0 is less than 2 times negative 2. And for our second one, we would have 0 is greater than or equal to negative 2 plus 1. 2 times negative 2 is negative 4. And then negative 2 plus 1 would be negative 1. So your two final inequalities are 0 is less than negative 4, along with 0 is greater than or equal to negative 1. 0 is not less than negative 4, so that does not check out. However, 0 is greater than or equal to negative 1, so that one checks out. However, negative 2, 0 is not a solution of both inequalities. And remember, for an ordered pair to be considered a solution, it has to be a solution of both of the inequalities within the system. So, negative 2, 0 is not considered a solution of the system. Now we'll be getting into how to graph a system of linear inequalities. We follow two basic steps. We're going to graph each inequality in the same coordinate plane and then do some additional steps to shade in our half planes. And then we're going to find the intersection of those shaded half planes, and that intersection is going to be the graph of the system. Now, rather than systems of linear equations where we had either one ordered pair, no solution, or infinitely many solutions as our answer, we are going to represent all of our answers to systems of linear inequalities through a graph. So I'll go ahead and show you how this works with our very first example. We have the system y is less than or equal to 3 and y is greater than x plus 2. Step 1 is to graph each inequality on a coordinate plane. The way I like to see it is I like to visualize the inequality symbol as an equal sign. So you're basically just going to be graphing the linear equations y equals 3 and y equals x plus 2. However, there are special considerations that you have to make. You must use a dashed line for less than or greater than, and you have to use a solid line for less than or equal to or greater than or equal to. So make sure that you're paying attention to your inequality symbol, and let's go ahead and start graphing. I'm first going to graph y is less than or equal to 3. Since we have less than or equal to, we know that this is going to be a solid line. And as a linear equation, that would be y equals 3. So you're just going to draw a horizontal line through the point 3 on the y-axis. So this is how our very first line will look like. And once you've graphed that, you can go ahead and graph your other equation or inequality. And this is greater than, so this is just going to be a dashed line. And as a linear equation, this would be y equals x plus 2. So this is actually in y equals mx plus b form, or slope-intercept form, where b is going to be your y-intercept, and m is going to be your slope. 2 is going to be our y-intercept, and our slope is actually going to be positive 1 over 1. So that means you're going to go up 1 unit and then run 1 unit to the right. You only need a minimum of 2 points, but I'll go ahead and do 3. And then you're going to draw a dashed line through your points, since again, our inequality symbol is greater than. And this is how your second line will look like. Now we're going to be moving into the shading portion. For step 2, you're going to shade each region either above or below the line depending on the inequality symbol. One thing to remember is that you're always going to shade below the line if it's less than or equal to, and you're going to shade above the line if it's greater than or equal to. So let's go ahead and look at our first line, which is y is less than or equal to 3. When you're looking at y is less than or equal to 3, try to disregard your other line and just pay attention to the inequality that you're trying to shade. As for y is less than or equal to 3, it is less than or equal to, so you know that you're going to shade below the line. So that would be this entire region that is below y is less than or equal to 3. Once you've done that, you can do this exact same for your other line. We have y is greater than x plus 2. Since it's greater than, you're going to shade above the line. So again, just disregard your other line. So in this case, disregard y is less than or equal to 3. And make sure to shade everything that is above y is greater than x plus 2. So that would be that region right there. And I recommend that you do each of your shadings with 2 different colors so that you're able to tell which portion belongs to which line and see the overlapment. So here is how your graph will look like once you've shaded in y is greater than x plus 2. And actually, when you are trying to represent your solution, you only want to include the area where the shading overlapped. So in this case, you see that the blue and the purple shading overlapped in this region right here. So your final graph would just include that portion of the graph. And here is how your final graph will look like. It does take a few steps, but once you get the hang of it, it's a lot easier. So let's go ahead and do a few more examples. We're going to graph this system. Our first inequality is 2x plus y is less than -1. The second one is 2x plus y is greater than 3. Now in our previous example, our inequalities were already given in slope-intercept form, so we just used the y-intercept and slope to graph. However, we can see here that our inequalities are in a different format. So I'm going to first rewrite these to set them to isolated x. Here is our next example. We have the system 2x plus y is less than -1, and 2x plus y is greater than 3. Now in our previous example, our inequalities were already set to y, meaning that they were in slope-intercept form, or y equals mx plus b. In this case, our inequalities are not solved for y, so let's go ahead and rewrite them so they are. We're going to be using inverse operations. First, we have 2x plus y is less than -1. All we have to do to isolate y is to subtract 2x from both sides, and that would give you this inequality, which is y is less than -2x minus 1. Second, do the same for 2x plus y is greater than 3. Again, you just have to subtract 2x from both sides, and that gives you y is greater than -2x plus 3. So your final system is going to be y is less than -2x minus 1, and y is greater than -2x plus 3. Now you can go ahead and graph these on the coordinate plane. Visualize the inequality symbol as an equal sign, so it's almost like a linear equation that you're just graphing. So for y is less than -2x minus 1, remember you're going to use a dashed line since this is less than. Our y-intercept is going to be -1, so plot a point at -1, and your slope is actually -2, and this is actually -2 over 1. So rather than going up 2 units, you're going to go down 2 units and run 1 unit to the right. You can do that for a few points, but again the minimum is 2. And once you've plotted all your points, you just have to draw a dashed line through them. Now that you've drawn your first line, you can go ahead and move on to the second inequality. Again, we're still going to be using a dashed line since this is greater than. As for our y-intercept, we're going to be graphing 3 for our y-intercept. So +3 would be right there. And looking at our slope, again it's -2. And since this is a whole number, it would just be -2 over 1. So rather than rising 2 units, you're going to go down 2 units and then run 1 unit to the right. So it would look something like this. You can do this for a few points. And once you've graphed all your points, go ahead and draw a dashed line through them. And there are your 2 lines. Now notice that our lines are actually parallel. And remember that whenever you have a system where you have 2 parallel lines, there is no solution. The way that you represent that a system of linear inequalities has no solution is by shading in your graph. So for y is less than -2x minus 1, that would be this line right here. It's actually a less than symbol, so you're going to shade below your line. And by shading below your line, which would be this portion right here, your graph should look something like this. And then you can go ahead and do the same for y is greater than negative 2x plus 3. In this case, it's greater than, and our line for negative 2x plus 3 would be right here. So since it's greater than, you're going to shade above your line, which would be this portion right here. And if you shade that in, your graph would look like this. And notice here how these shaded portions never intersect or overlap. So that's how you know that there is no solution to your system. Here is another example for us to try. We have the inequality y is greater than or equal to 1/2 x plus 1, and our other inequality is y is greater than 2x minus 3. In this case, if we visualize the inequality symbols at equal signs so that they are linear equations, they are actually set in slope-intercept form, where b is our y-intercept and m is our slope. So we can go ahead and graph both of our equations using the y-intercept and slope method. For y is greater than or equal to 1/2 x plus 1, this would be a solid line since we have greater than or equal to. Our y-intercept would be positive 1, and our slope would be positive 1 over 2. So you're going to rise 1 unit and run 2 units to the right. So let's go ahead and graph that. Our y-intercept is positive 1, and then if you were to plot another point using your slope, you would rise 1 unit and go 2 units to the right, so there would be your second point. And again, this is going to be a solid line since we have greater than or equal to, so draw a solid line through all your points. Now that you've graphed your first line, you can go ahead and move on to the second inequality. Again, this is in slope-intercept form, so you can go ahead and use your y-intercept and slope. In this case, your y-intercept would be negative 3, and your slope is positive 2, and when it's a whole number, that would just be 2 over 1. So you're going to go up 1 unit and run 1 unit to the right. So first graph your y-intercept, which is negative 3, and then you're going to rise 2 units and then run 1 unit to the right, and then plot your second point. You can do a third point if you'd like, and then you're going to use a dashed line since this is greater than. So draw a dashed line through all your points. And now we can shade in our graph. I'll go ahead and start with shading y is greater than 2x minus 3, since that is the line that we just graphed. In this case, y is greater than, so since we have a greater than symbol, you're going to want to graph or shade above the line. Remember, y is greater than 2x minus 3 is this line right here, so you're going to want to shade the entire portion of the graph that is above your line, and that would look something like this. And now you can do the same for y is greater than or equal to 1/2 x plus 1. Remember that that line would be this one right here, and since it's greater than or equal to, you're also going to shade above the line, and that would be this portion right here. And if you were to shade that in another color, it would look something like this. And remember that to represent your solution, you only want to include the portion where the shadings overlap. So you would erase your shading right here and in this portion, and just keep this shading that is right here. And your final graph would look like this. Here is another example that we're going to try. We have y is greater than or equal to negative x plus 4, and x plus y is less than or equal to 0. First, I want to rewrite this equation right here in slope-intercept form so that it's easier for us to graph. So if we have x plus y is less than or equal to 0, to isolate y, you would simply subtract x, and then that would give you y is less than or equal to negative x plus 0. And now that you have both of your equations in slope-intercept form, you can go ahead and graph them. For our first inequality, we have positive 4 for our y-intercept. So I'll go ahead and plot that point. And our slope is actually negative 1 over 1. So you would go down 1 unit and run 1 unit to the right. So if I were to do that from our y-intercept, I would go down 1 unit, run 1 unit to the right. And you can do that a few times if you'd like. And once you plot your points, you're going to draw a solid line through your points, since this is greater than or equal to. So your line would look something like this. And now you can move on to your second inequality. We have y is less than or equal to negative x plus 0. In this case, our y-intercept is going to be 0, or the origin, which would be right here. So plot your y-intercept, and from there you can draw other points using your slope. Again, your slope is going to be negative 1, so that would just be negative 1 over 1. And since it's negative, rather than doing rise over run, you're going to go down 1 unit and run 1 unit. Do that a few times to get a few points. And once you've plot all your points, we can go ahead and draw our line. In this case, it's going to be solid since we have less than or equal to. So draw a solid line through all your points, and here is your graph. Now we're going to shade in our graph. For our very first inequality, we have y is greater than or equal to negative x plus 4. Make sure that you're looking at the right line. That inequality would be this line right here. And we have greater than or equal to in this case. So you're going to shade above the line. Shading above would mean all of this portion of the graph right here. And if you were to shade that in, it looks something like this. As for x plus y is less than or equal to 0, that would be this other line right here. And it's less than or equal to, so you want to shade below the line. And shading below the line would be this portion of the graph right here. And if you were to shade that entire region, it would look something like this. We know that whenever we have parallel lines in a system that there is no solution. In the case of linear inequalities, we represent that through our shading. We see here that there is no portion of our graph where the shading overlaps. Their purple region is separate over here, and our blue region is separate over there. So we know that there is no solution to this system of linear inequalities. Now we will be moving into these types of problems. We're going to write a system of linear inequalities that is represented by the graph. So looking at the lines that are plotted and the shaded regions, we're going to have to make two different inequalities that are represented in this graph. I'm going to start off with this horizontal line right here. It's passing through the point -2 on the y-axis. And we know that horizontal lines are represented by the equation y equals to a certain point on the y-axis, which in this case is -2. Now looking at the line, it's solid, so we know that it's going to be either less than or equal to or greater than or equal to. The way we know whether it's less than or equal to or greater than or equal to is by looking at the shaded region on the graph. In this case, we see that the shaded region is above our boundary line, so we know that it's going to be greater than or equal to. So as for this line right here, it's going to be y is greater than or equal to -2. And let's just go ahead and summarize the reasoning. The shaded region is above the solid boundary line, so the inequality is going to be y is greater than or equal to -2. Now you're going to do the exact same process for your other line right here, except this time we're going to have to find the actual equation of the line. The way we do this is we want to first find our y-intercept, which is actually 0, and then find two solid points on your line. I'm going to go ahead and use our y-intercept and 1, 1, and you're going to try and find the slope. So we have rise 1, and then go over 1, then rise 1, and then run 1 unit. So we know that rise 1 unit over run 1 unit means our slope is just 1. And if we were to put this together, where our slope is 1 or +1 and our y-intercept is 0, it would mean that in y equals mx plus b form, it would be y equals to just x, since you don't necessarily have to write the 1 in front of your variable, and then plus 0, or it could just be y equals x, no need to include the 0. And then you can go ahead and determine the sign of your, or inequality symbol of your line. So looking at our line, it's a dashed line, so we know that it's either going to be less than or greater than. And the way we determine this is by looking at the shaded region. The shaded region is actually below our line, so we know that this is going to be less than. That would be y is less than x. So let's go ahead and summarize our reasoning. The shaded region is going to be below the dashed boundary line, so the inequality will be y is less than x. Our final solution would be the system is y is greater than or equal to -2, and y is less than x. Let's go ahead and look at this next example. We're going to write a system of linear inequalities represented by the graph. So I'm going to start off with our vertical line right here. Looking at our vertical line, we see that it passes through the x-axis at +3. And remember that a vertical line is x equals to a certain point on the x-axis, which would be 3. So we know that our equation is going to be x equals 3. However, we have to replace our equal sign with an inequality symbol. Looking at our line, it's dashed, so it's either less than or greater than. The way we determine this is to look at our shading. Now notice here that this is actually a vertical line, so you can't have your shaded regions either below or above your line. So the way you determine this is whether it is to the left or to the right of your line. In this case, it's to the left towards the negative side, so we know that it's going to be less than. So your final inequality would be x is less than 3. For our other line, let's first find its y-intercept since we have to make an equation. Our y-intercept would be +2, and then you want to find the slope, so go from a solid point here and then keep counting your solid points. So I'm gonna do 0, 2, and then 1, 1. In this case, we're actually going down 1 unit and running 1 unit to the right, going down 1 unit and running 1 unit to the right. So instead of rising 1, we're going down 1, and then we're still running 1 unit to the right. So in this case, our slope would be -1. Putting this in slope-intercept form, our slope would be -1, or you can just put -x, and then plus our y-intercept, which is 2. And now let's replace our equal sign with an inequality symbol. Looking at our line, it is dashed, so we know it's either going to be less than or greater than. So look at your shaded region. Looking at the shading, it's actually below our line, so we know that it's going to be less than. So our final inequality would be y is less than negative x plus 2. So the boundary line represents the linear equation y equals negative x plus 2. The shaded region is below the dashed boundary line, so our final inequality is y is less than negative x plus 2. And these are the two inequalities that make up our system. Here is another one of those examples. We're going to write a system of linear inequalities represented by the graph. Looking at this line right here, we know that the y-intercept is negative 3, intercepts the y-axis right here, and then we're going to find the slope by counting each of the solid points. So I see a solid point right here, another solid point right there, and another solid point right here. And we're rising 2 units and going 1 unit to the right, rising 2 units, running 1 unit to the right. And we're doing that for several points on our graph. So we know that our slope is positive 2 over 1, which would just be 2. Putting this into y equals mx plus b form, remember that our slope is positive 2, so that would be 2x. And then your y-intercept would be negative 3, so that would just be minus 3. And now we're going to replace our equal sign with an inequality symbol. This is a solid line, so it's either going to be less than or equal to or greater than or equal to. Looking at the shaded region that is below our boundary line, we know that since it's below the line, it's going to be less than or equal to. So your final inequality would be y is less than or equal to 2x minus 3, which is right here. Do this exact same for your other line. First, find your y-intercept. That would be positive 1. And now you can find your slope. We're actually going to go down 1 unit, and then here is another solid point right here. So go down 1 unit and run 2 units to the right. Go down 1 unit and run 2 units to the right. And then go down 1 unit and run 2 units to the right. And we see here that our slope is actually negative 1 over 2. And that our y-intercept is going to be positive 1. So plugging it into y equals mx plus b, it would be y equals to negative 1/2 x plus 1. And then you can go ahead and replace your equal sign with an inequality symbol. The line is solid, so it's either less than or equal to or greater than or equal to. Looking at our shaded region, it's actually above our boundary line. So we know that our symbol is going to be greater than or equal to. So your final inequality would be y is greater than or equal to 1/2 x plus 1. So for your final system of inequalities, it would be y is less than or equal to 2x minus 3, and y is greater than or equal to negative 1/2 x plus 1. That is it for today's lesson. Thank you so much for watching. If you ever have any questions regarding the lessons, please feel free to reach out to me at kaylin.david24@gmail.com. As always, all information regarding tutoring requests, lesson requests, and additional practice will be linked down below in the description box. I hope to see you in the next video.